You know this one scene from the 2009 Sherlock Holmes film where he's fighting in the cage and predicts his opponent's every move?
First, distract target. Then block his blind jab. Counter with cross to left cheek. Dazed, will attempt wild haymaker. Employ elbow block.
It's crazy impressive, and I'm sure you're asking yourself, how on earth does somebody read another person like that so accurately? But now imagine if that wasn't just a fictional genius, but a real AI that can predict your every decision before you even make them. Well, earlier this year, researchers introduced a new AI model called Centaur, and it's a big deal because Centaur could be the first step toward creating an AI that literally knows you better than you know yourself. If that doesn't sound both fascinating and terrifying, I don't know what does. I've linked the research paper in the description if you're interested, but in this video we're going to break it all down, what Centaur is, how it works, and if this means we're a step closer to conscious AI. Let's start with a simple question. Why is Centaur such a big deal? Think about your brain. It's incredibly versatile. Every day you make thousands of decisions, from simple ones like what to eat for breakfast to complex ones like solving problems at work. Take someone like Elon Musk. He's juggling decisions about rockets, AI, and electric cars. The human brain is amazing at generalizing across wildly different tasks. AI, though, not so much. Most AI models are domain-specific. They're great at doing one thing, but take them outside their primary function, and they fall apart. Similarly, in cognitive science, we have theories like prospect theory, which explain decision-making well, but don't tell us much about how we learn or plan. If we want AI to truly match human intelligence, or even surpass it, we need something more versatile, something domain general. That's where Centaur comes in. Newell, a prominent figure in cognitive science, stated that unified theories of cognition are the only way to bring our wonderful, increasing fund of knowledge under intellectual control, and the development of Centaur is the first step toward doing that. It's what researchers are calling the first foundation model of human cognition. It doesn't just excel in one area, it's designed to generalize across many. Centaur was trained on a dataset called Psych 101, which is basically a treasure trove of psychological data. We're talking about trial-by-trial data from 160 different psychological experiments involving over 60,000 participants who made a whopping 10 million decisions in total. This dataset spans all kinds of domains: decision-making, memory, problem-solving, and more. At its core, Centaur is a large language model, fine-tuned from Meta's Llama 3.1. But its purpose goes far beyond generating text. In tests, Centaur wasn't just good at modeling human behavior, it consistently outperformed existing cognitive models and even started to reflect human neural activity. Researchers put Centaur through a series of rigorous tests, and here's what happened. First, it predicted human behavior better than other models. For every task, researchers split the data into 90% for training and 10% for testing. They used a scoring system called pseudo-R-squared to measure how well each model predicts human choices. A score of 1 means perfect predictability, while 0 is equivalent to random guessing. In panel A on the left, we can see that Centaur consistently outperforms the other models on all tasks, and it's shown also with the overall value at the top. For tasks like the go, no-go and serial reaction time, Centaur achieves near-perfect scores. But there are certain tasks like predicting the weather and shepherd categorization, where all the models perform far worse, and the difference between them is smaller. And it's understandable that these tasks are far more challenging when we're talking about human cognition. Researchers also tested Centaur with progressively complex scenarios to assess its ability to generalize beyond its training data. On the left, Centaur successfully handled changes in cover stories. In a decision-making task, it adapted from spaceships exploring planets to magical carpets, achieving a pseudo-R-squared score of 0.26, outperforming both Meta's Llama 0.10 and domain-specific models 0.12. The middle part shows results of testing on the Maggie's Farm task, which introduced an extra choice to a decision-based task and altered the decision-making structure. Yet Centaur still excelled with a score of 0.62, compared to Llama's 0.43 and cognitive models 0.11. This demonstrates its ability to adapt to more complex problem structures. In logical reasoning tasks, an entirely novel domain excluded from its training data, Centaur still achieved a meaningful score of 0.18, outperforming Llama's 0.05. This shows its strength in extending its understanding into uncharted areas. Now here's the really interesting part. researchers investigated whether Centaur's internal representations, developed solely through training to predict human behavior, would also align with actual human neural activity. Centaur was first tested on fMRI data from participants performing a two-step decision-making task. It accurately predicted neural activity in various brain regions both before decisions and after receiving feedback. The results, shown with R-squared scores, demonstrated Centaur's superior performance compared to Meta's llama and traditional models, which barely exceeded chance levels. This highlights Centaur's strong alignment with human neural patterns, achieved through fine-tuning on behavioral data. In a second analysis, Centaur predicted fMRI data from a task where participants read 6-word sentences unrelated to its training data. Centaur's predictions were most accurate in intermediate layers of its architecture, which are key for decoding brain activity. Fine-tuning further improved performance across all layers, consistently outperforming llama. Though modest, this improvement underscores Centaur's ability to generalize to new scenarios, like predicting neural responses to language. Importantly, this was achieved without explicit neural training, demonstrating Centaur's potential to connect behavior and brain activity in cognitive modeling. With the call for unified theories of cognition, a set of criteria was developed that a unified computational model should fulfill, and it's believed that Centaur is the first model to satisfy the majority of these criteria. But there are 3 it doesn't fully satisfy, and the one I want to mention is exhibit self-awareness, or a sense of self. As a model, Centaur lacks consciousness. However, it shows a practical form of self-awareness by modeling individual-specific information. Trained on diverse population data, Centaur can distinguish between people, identifying traits like preferences and decision-making patterns to predict future behavior. While not true self-awareness, this dynamic adaptation demonstrates its ability to create personalized representations of individuals. Regarding the Psych 101 dataset, future plans include expanding beyond learning and decision-making to fields like psycholinguistics, social psychology, and cross-cultural studies. This will address its current bias toward a Western, educated, industrialized, rich, and democratic population, or WEIRD, if you like acronyms. By encouraging open collaboration, the next iteration of Psych 101 aims to standardize psychological data for benchmarking and complement existing neuroscience efforts. Unified models of cognition have historically faced resistance from traditional disciplines, and this is not uncommon among scientific fields. Similar opposition greeted Einstein's theory of relativity, initially dismissed for contradicting Newtonian physics. To encourage acceptance, a cognitive decathlon was proposed, testing competing models across 10 rigorous experiments. Centaur exceeded expectations, participating in the equivalent of 16 such decathlons. Now, the research paper covers way more like the experimental methods used and the machine learning models in detail. So if you want to check it out, I've added the link in the description below. If you enjoyed the video, please leave a like. And don't forget to subscribe for more content on AI, robotics, and so much more.